Thank you, Lane, and good morning, everyone. Welcome to day 2 of our synthesis of the science. Today, we're going to get started on the topic of phytoplankton and zooplankton. I'll just say this is a really important topic because it's one of the ways we can link together the physical processes and the upper trophic levels that we talked about yesterday. And we're very fortunate today to have Kevin Freeland, who is a scientist at NOAA Fisheries, here to talk to us about those topics. With that, I will toss it over to you, Kevin.
Thank you and good morning. So I'll start by sharing my screen. So what I'll talk to you today about is the lower trophic levels on the Northeast Shelf ecosystem, which the phytoplankton community is dominated by relatively large size phytoplankton, diatoms, dinoflagellates, and chlorophytes, which are a bit different than most of the world's oceans, which are dominated by cyanobacteria. And the zooplankton community contains a blend of copepods and also larval forms of things like barnacles and worms. But it's an interesting ecosystem in terms of copepods because we have a blending of both boreal and tropical and temperate species. For example, Calanus finmarchicus, which is more a North Atlantic species, finds its southern range down in our ecosystem. And this is an important component of the zooplankton community. The distribution of chlorophyll or primary production on the Northeast Shelf is focused close to the shore, but also there are features that are important. For example, George's Bank, which hopefully you can see my pointer, is a raised bank that has a lot of vertical mixing, so it has enhanced productivity, as also in the Nantucket Shoals area. But as you can see, the productivity or the concentration of chlorophyll diminishes as you go further offshore to the offshore blue tones typical of open ocean ecosystems. So the prospective wind area, lease areas for the Northeast Shelf are right now focused in the Mid-Atlantic Bight. And I show these, but also superimpose upon this the outline of 4 ecoregions that we use to characterize the Northeast Shelf, but in particular the Mid-Atlantic Bight, which is outlined in blue, George's Bank, and the Gulf of Maine. And I use these areas to characterize or give you a sense of the annual pattern of productivity in the Northeast Shelf. And so what I've superimposed on these series of graphs is during the month of the year, the level of chlorophyll, but then also the level of primary production that occurs. And the primary production is shown in the red curves. And you notice that in all these areas, George's Bank, Gulf of Maine, and Mid-Atlantic Bight, you have a peak in primary production that occurs in the summer months when there's the maximum amount of solar radiation. However, I would stress that this productivity is mostly up in the water column and doesn't necessarily represent a lot of new production, as compared to the green lines, which are the biomass of chlorophyll. And they peak diagnostically in George's Bank and Gulf of Maine in the spring, but then also in the fall. These are the spring and fall blooms that occur. And these are important features for fisheries because when the blooms occur, this is when the productivity of the phytoplankton exceeds the grazing ability of the zooplankton field to remove the phytoplankton. And this is when the most flux of phytoplankton energy goes to the benthos and feeds bottom organisms like fish and shellfish. But I would also stress that we see a very distinct pattern of spring and fall blooms in George's Bank and Gulf of Maine. However, the Mid-Atlantic Bight really does not have these features very well developed. It tends to have high chlorophyll concentrations during the winter months, so a very different pattern in that part of the world. This is a figure out of a paper that just came out, as a matter of fact. It went live a few days ago, where we looked at trends in temperature, salinity, and chlorophyll on the Northeast Shelf. I will zoom in on panels A, B, and C, but before doing so, I would point out 2 things. One is that the time series for these data is from 1998 to 2019, which was limited by the availability of ocean color data from the satellites. And then the balance of the figures beyond panels A, B, and C are for other ecoregions along out in the Northeast Shelf, but I won't go into that detail. But let me home in on A, B, and C to give you a sense of what we're seeing in this ecosystem. The top panel is sea surface temperature, or the Northeast Shelf, the annual mean sea surface temperature. And it's marked quite dramatically by the highest temperature recorded for this ecosystem in 2012. However, the other important feature that has emerged since then is that we seem to be in a different regime or a different level of temperature on the shelf. We've warmed quite dramatically. And this has been accompanied by a shift in salinity, the center panel B, but then also of great importance to us when we're looking at resource species is that after this high temperature change occurred, we've seen a monotonic decline in chlorophyll concentrations. I would note that there was a level of stability in chlorophyll, the phytoplankton populations prior to these years, around 1.5 milligrams per meter cubed, which is very typical of a highly productive ecosystem, and when we compare that worldwide. However, at these levels of only a milligram per meter cubed, this is more typical of very low yield or low production ecosystems. In addition to looking at trends in temperature and chlorophyll and salinity, in the same report, we did some analyses to quantify or look at the quality of the phytoplankton community using a number of different models to characterize cell size, but then also functional types of phytoplankton. The first analysis I'm highlighting here estimates the cell size distribution in the phytoplankton community. And what we noticed is that the larger size classes, the microphytoplankton, which are greater than 20 microns, have decreased quite dramatically in the Northeast Shelf, whereas nano and picophytoplankton have increased. Two types of remote sensing based functional type analyses suggest that diatoms have decreased, which are diatoms stressing that the diatoms are an important food component for many species. But the last data element, which sort of ties it together, is that we have continuous plankton recorder data for the Northeast Shelf. And these are direct counts of phytoplankton cells. And when we look at these data, we see that the diatoms have also decreased in the direct counts as well to sort of substantiate the other data. In a report that just came out from Zhu et al., they looked at patterns of chlorophyll variability in the Northeast, on the Mid-Atlantic Bight segment of the Northeast Shelf. And they found that the outer part of the Mid-Atlantic Bight is more classically controlled by vertical structure of the water column. In other words, associated patterns of chlorophyll with wind mixing events that relocate nutrients up into the upper layers. However, the inner part of the Mid-Atlantic Bight shelf, the patterns of chlorophyll variability seem to be associated a lot with the river discharges coming out of the major estuaries like the Chesapeake, the Delaware, and the Hudson, suggesting that there are two sets of forcing factors controlling the primary production on the shelf. And as we talked about yesterday, an important feature that would control the redistribution of nutrients is this vertical structure MAB cold pool feature, which has to do with the segregation of the cooler, more nutrient-rich waters in the bottom versus the depleted surface waters where phytoplankton are occurring. The zooplankton communities on the shelf change or vary seasonally. What we're looking at here are zooplankton biovolume, which is a bulk measure of zooplankton biomass. You see that in the spring, the main focus of zooplankton is on Georges Bank, and in the fall, more along the Mid-Atlantic Bight. However, in the bottom panels, spring trend and fall trend, these show that the differences or change over time in these communities is spatially complex, and we have to be aware of that. This is one of the more important zooplankton taxa that occurs in the Mid-Atlantic Bight, Syntropodes typicus. Again, also you see this pattern of seasonal movement and spatial change. This is a paper that was published a few years ago by Morse et al. Looking at zooplankton communities in abundance. And I won't go into the detail of the findings other than to point out that the left-hand figure is an analysis of zooplankton community structure. And I would stress that what you should notice is that we see very distinct breaks in the composition of the zooplankton community over time. species exchange, and also body type or body size changes that occur on a decadal scale. And the right-hand panel emphasizing the change in relative abundance by region and over time as well. In a paper that we have in review, we analyze, I'm switching gears here now, we've been analyzing the fish habitats for taxa that occur on the Northeast Shelf. This is an example of the output of these machine learning models for summer flounder. And we can characterize spring occurrence and fall occurrence, and then also rate of change of these models. The thing about these models is that they're informed by not only the typical variables of depth and temperature, but we also include lower trophic level variables in the analyses. And what we find is that variable importance analyses suggest that primary and secondary production variables are very important. The way you read these variable importance plots is in the left-hand plot, the variables are up in the upper left quadrant. These are the most important variables. And we see that physical, primary, and secondary production variables turned out to be quite important, whereas terrain variables were less important. And then the opposite is in the right-hand plot. In this variable diagnostics, variables in the upper right-hand corner are most important. Again, the primary and secondary production variables emerging for these fish taxa. This is a multivariate analysis of the same set of species that are occurring in the lease areas, where we look at a multivariate analysis of variable importance, and not surprisingly, bottom temperature and depth are important variables to define their habitats. But as you scan down, the blue and the green variables, which emerge as important variables for these fish, defining these fish habitats, many of them are chlorophyll variables in green, or the blue are zooplankton variables. These models also allow us to start to rank or give a general idea of which taxa have a high dependency on the lease areas. We then score the occurrence of these species in the lease areas to characterize high, moderate, low, and relatively speaking, no dependency on lease area habitats for these fish taxa. I won't go into the detail that was covered yesterday, other than to emphasize that everything we saw yesterday in terms of the perturbations that occur in the water column can affect phytoplankton and zooplankton in many different ways. So wind wakes that are occurring from turbines, if they impact water column turbulence, that can impact the manner in which zooplankton and phytoplankton interact. If the wind wakes are changing vertical structure and they mix layer depth, these are important parameters to the development and the way blooms are sustained in the environment. And I thought this is an interesting figure. I don't know if it appeared yesterday or not, but just to see how pervasive these mixing effects can be in a wind farm setting. So to summarize, the important thing to remember about chlorophyll and the lower trophic level of phytoplankton communities is that we're seeing a new range of variability. So we have to be cognizant of that in terms of going forward and any monitoring that we do in respect to the installation of the wind farms. Likewise, with zooplankton abundance and community structure, we've seen these communities shift and change. And so we have to be, again, cognizant of those as we design our monitoring programs. Fish habitat models suggest that there's a high reliance on these primary and secondary predictor variables, suggesting that these lower trophic levels are important to these species. And so we are concerned about any changes that will be occurring in the lower trophic levels. And then, as we just mentioned, the foundation effects on water column structure and properties within the water column itself and their effect on lower trophic level production. So that's what I have, and hopefully I came in on time. We're close.
Great. Lisa, I was going to jump into some questions, but first I want to see, Lisa, if you wanted to add or anything or engage with Kevin at all before I do so.
Hi, Pat. No, I think let's jump into some questions and see how we do.
Awesome. Okay, so Maggie, if we could open the chat. So if you can use Mentimeter, which is the URL is in there in the chat, that's best just for me to keep track of questions in one place. But if you can't, it's totally fine to use the chat function as well. So that's going to be open as well for anybody and everybody will see the comments you make. So Probably not surprising, Kevin. The questions, which I think you probably addressed, but maybe you can say a little bit more, is I'm going to name two, but I think they're pretty much the same, which is that, does turbidity affect the production of life cycle of phytoplankton and zooplankton? And kind of really trying to understand the foundations in the water, whatever form they might be in, and kind of this sort of, when we saw yesterday, kind of the wake images and the turbulence and the like, is it going to actually cause kind of persistent phytoplankton blooms or change the productivity in some meaningful ways, especially since you noted that fish populations and those various sort of amounts of phytoplankton and zooplankton are pretty highly correlated?
Yeah, so starting off with the turbidity issue, anything that changes the penetration of light energy into the water column can potentially affect the productivity of the phytoplankton. I would extend that to not only limiting our thinking about turbidity in context of phytoplankton, but also remember that fish predators are often very dependent on their ability to see through the water column. So there's a lot going on with turbidity.
Great. And the question about, let me frame this as a science question, but I think there's a question about kind of keeping track of these kind of secondary variables. So obviously you talked, I think, about bottom temperature and depth, but there's all these other measurements of zoo and phytoplankton. And in order to actually kind of collect that data, is there an existing observing or monitoring system already collecting that data regionally to some extent? Is that something that you actually need to do more localized? What's the kind of complexity of gathering that data?
So we have a powerful tool for phytoplankton in the sense that we have a high reliance and make great use of the satellite data. So that's quite comprehensive and gives us the ability to analyze spatial and temporal changes in surface chlorophyll that can't really, it's very hard to match by in situ sampling. The expectation is that we have a database of that information prior to any installation of any wind farms that would continue after the installation, in the sense that the satellites are still up there and continue to be deployed. As far as zooplankton goes, we've been drawing heavily upon our surveys that are done by the Northeast Fisheries Science Center. And so these are systematic seasonal surveys that do net captures of zooplankton communities and identify the taxa that occur there. So the expectation would be that in some way, shape, or form that we'd be able to continue those surveys, so that, again, we would have sort of a depiction of before and after effects that we would attribute to changes in the zooplankton community. That's sort of a very important issue that a number of folks are taking on right now in terms of how to continue those surveys in light of the need to change study design.
Great. There was another question about, Kevin showed a ranking of species that are more or less dependent on lease area habitats. How unique are they to the lease areas versus more regionally wide?
Yeah, it would be fun to be able to go into great detail. I'll go into a little slightly more detail, but we worked up a rating system that looked at not only the strength of the habitat score for a species in respect to what's occurring in the lease area, but we also worked out a ratio estimator that looked at the habitat score in regard to the balance of the entire ecosystem. So scoring high in both really sort of cements that these are very important regions, or the lease areas represent very important regions to these taxa. So for example, a taxa like redfish will have an extremely low, if not almost a negligible habitat score in the lease areas, but a very high outside the lease areas. Whereas something that like summer flounder will have a very high score in the lease areas, and it'll be a high score in respect to the entire ecosystem.
Right. Generally, I'm typically in the plenary not calling on hands, but we're actually doing fine for time here. So I'm going to go ahead and do that, make an exception, because I see a hand or two. And if we have time, I'll allow for that. And if not, we'll just use Mentimeter and chat just to keep things moving. So Tony, I'm going to unmute you. So you should be able to speak.
Thank you. Can you hear me, Patrick?
Yes, we can hear you. Okay.
Dr. Freeland, thank you very much. It was a very interesting, wonderful presentation. My question has to deal with primary productivity and nutrients. Naturally, primary productivity is dependent upon the availability of nutrients in the water column. Do you see, or do you anticipate any effect that the foundations would have in a sense, bringing nutrient-rich colder water to the surface to feed the plankton in the upper layers and increase primary productivity?
That's
Thank you.
certainly a possibility. Yeah, if I saw on the plots yesterday that the mixed layer depth can increase in the shadow of these deployments. So that would suggest that the potential for mixing more nutrient-rich, deeper water into the surface layer is there. But however, you have to be mindful of the complexity of the situation in the sense that primary production is dependent on a mixed layer that does not take the phytoplankton out of the sunlight too much. So if you deepen the mixed layer, you may increase the nutrient concentration in the water column. But at the same time, you have the problem that you may be taking the phytoplankton into more shading if they're being mixed deeper. So, you just have to be mindful of the variety of issues that will come forward as we try to understand the mixing effects.
Great. Thanks, Tony. Great question. There's a question about, I think, this interaction of various variables. So it's of critical importance to immediately assess the areas of glacial moraine and benthic habitat to work on the relative importance of the structure versus the physics versus the productivity. So I wonder if you can speak to kind of more of the structural elements tied with kind of the mixing, tied with kind of the nature of phytoplankton and zooplankton, and how we can think about those together.
Wow, I didn't get the thread of the question there.
It says, let me just read it one more time, sorry. It is the critical importance to immediately assess the areas of glacial moraine and benthic habitat. So essentially understanding the benthos better, and then its relation to structure, physics, and I think productivity, in addition to the things you mentioned around mixing and all of those things. So I don't know if there's ways we can think about those collectively or just at the point noted.
I'm not sure what the question is. I mean, what we've covered so far is the concern about mixing, producing changes to the mixed layer depth and then also the turbulence within the water column. How that will interact with the bottom type, I don't know. It'll depend on the part of the shelf that's occurring. I guess for the more inshore, the inshore release areas, the bottom feeling might be more prevalent, but as you get further offshore and 50 meters or so, I'm not sure if that's going to be an important factor.
Thank you. What do we know about European wind farms and productivity in and around the wind farms and phytoplankton and zooplankton?
I'm not the expert on this, so maybe Lisa can join in as well. But there's been not a lot of work done on it, and I off the top of my head, I'm not really equipped to talk about it.
Great, Lisa, is there anything you want to add to that?
Trying to turn my camera on. Yeah, I can kind of second what Kevin said. There hasn't been a lot of work done on that topic just yet. So it's we're still learning, and it's something we want to think about here in the U.S. because there hasn't been a lot done over in Europe.
Okay, great. So again, an area for rich and further and needed exploration. So there's a question in the chat, which is, I think it's really about obviously putting structures in the water, and then it also may have attracting features in some cases, say for seabirds. So do seabirds add important nutrients for plankton when they're in high numbers or abundance in terms of how the seabird population might actually affect abundance locally?
Abundance of phytoplankton?
Yeah, exactly, or zooplankton.
I have no idea.
All right, we're getting some stumping questions. That's good.
Yeah. I mean, they're out there, but I don't know if they represent a tremendous input of nutrients or recycling or not.
Okay, great. And Drew just provided a kind of clarification around the glacial moraine, the benthos. So just, I think, to note there. The question, are the filter feeding organisms, I think we saw a lot about mussels yesterday, that would attach to the turbine bases or structures likely reduce the abundance of plankton and or significantly affect the system overall because of this change in species composition and abundance?
Well, they'll definitely remove phytoplankton from the water column. Whether there's enough substrate to make a systems difference, I don't know.
There's a question about, if you're willing, making some educated guesses about how offshore energy might affect kind of food chains overall when you think about, what you've just covered. You're welcome to make an educated guess or refrain from doing so if you choose to. So up to you.
Well, you know, I've already speculated in a lot of things that I said. I mean, if the turbines, and we have, you know, very dense wind farms, lots of structure out there, and it really changes the mixing and turbulence in the water column, then we may see a very demonstrative change, and it may be greater productivity and maybe less productivity. We'll have to see.
Great. And one question is a bit of a policy question, but let me reframe it as a science question. So, are there thresholds of productivity change where you would become concerned? For instance, things are changing a little bit, everything looks good, and there's somehow some tipping point or some very within quick change in a direction that would have concern you in terms of the broader ecosystem.
Well, I sort of sounded that alarm already, in the sense that, you know, in global analyses, ecosystems with chlorophyll concentrations that are sort of in the ballpark of 1.5 milligrams per meter cubed are highly productive, high fishery yields ecosystems. That's where we were. Currently, we've declined into a level of about 1 milligram per meter cubed, which is very typical of lower yield fisheries systems. So, you know, the alarm is already out. That's why, you know, I think it's important to have our eyes open in terms of a level of climate-induced productivity change that we've seen that has nothing to do with turbines, because they're not in the water yet. And so we have to be mindful of changes that are occurring from other forcing factors as we try to take on the challenge of understanding what perturbations may be attributed to the wind farms as well.
Complicated yesterday in terms of separating those things out for sure. Another question is if the, see, just the Mentimeter moves around as we go. If the inner versus outer mid-Atlantic bight is more influenced by river discharges versus wind mixing, is chlorophyll higher in winter months throughout the mid-Atlantic bight, or does that pattern vary with distance from shore?
I have not looked at it specifically. I have a feeling that they track each other, but I'm not 100% sure.
Great. So I think there is a comment in the chat about kind of several papers in Europe about muscle building and phytoplankton structure. I think there's a point about this is complicated, and so how all these things interact together and what the ultimate output or result will be, we're probably not going to know. There's a question about if we do see greater productivity blooms from wind mixing. So if we do, would it be possible to see lower oxygen concentrations and even OMZs?
Yeah, the Mid-Atlantic bight has some interesting terrain, in the sense that when New York City was depositing its refuse at a dump site 12 miles off the shore, quite infortuitously, they were dumping in the one location on the Mid-Atlantic bight, it would seem, that would cause anoxia. There are some swales or some depressions in the Mid-Atlantic bight that can retain nutrients and also, you know, cause low oxygen stress. So we've had events in the past that have been associated with low oxygen on the shelf. So, you know, it is not impossible to think that we could have oxygen stress again in the Mid-Atlantic bight if there are significant changes to the system.
Great. All right. I think that I'm just going to check to make sure. Let me try this out as a summary to see if you agree. So I think someone in the Mentimeter just noted, would it be fair to summarize your presentation as warming is affecting primary and secondary productivity, and wind farms may as well?
That's fair enough.
All right, short and sweet. Kevin, I think we're approaching our time, but I want to just give a minute to see if there's any other final questions in Mentimeter or on the chat. And then if there's anything else you or Lisa want to cover as we wrap both this section up and sort of our ecosystems effect section up altogether. And maybe here's actually a good one is let me just gather this one, is what is unique about this region to make us think differently from other regions of the oceans? When we think about this, what jumps out as significant or unique about this region?
The Northeast Shelf or the Mid-Atlantic bight, and unique in terms of its productivity? Is that what they're getting at?
I think so. Yeah, maybe you can talk about both. Bight and above.
Well, I mean, the continental shelf seas are unique from the world's oceans in that, you know, because of their bathymetry and proximity to the land, they have conditions that facilitate high productivity. And we have, though they represent a relatively small fraction of the world's oceans, they represent a dominant fraction in the production of seafood. And so the problems that we face in terms of understanding what wind structures will do to the ecosystem are probably not unique, and from what the experiences that we've had elsewhere. And I think that we'll be able to learn from each other.
Thank you. And I just note from Jens, there's a comment about a study done in 2019. Just I think I'll kind of note that to the side. That's in the chat. That's what.
Super. Yeah.
All right. Kevin and Lisa, thank you very, very much. Really appreciate it. Thanks for this great presentation. I think it's actually a good wrap up for thinking about kind of the ecosystem's effects that we were talking about yesterday. So appreciate it. One last question, so I got 2 minutes from Eric, is what about the possibility of increasing red tide and PSP because of any of these changes?
I guess anything's possible.
Great, we'll leave that at that. Kevin and Lisa, thank you, really appreciate it.
Thank you.
Great, so remember folks, we will be saving both the chat and the Mentimeter, so we make sure that the chapter authors have that information and the like. And so we're not going to lose that. Thanks for the good discussion. Okay, so we are now